Hello students, welcome back to Shiv Physical Science Zone. In this lesson, we are going to understand changes around us and the language of chemistry from physical and chemical changes to elements, symbols, combining capacity, formulae and molecules. Let us learn these concepts with simple examples and questions. Let us begin now. Explain the type of changes involved in the below chart. Case 1, melting. So ice changes into water, only the state changes, that is solid to liquid, no new substance is formed. It is a reversible change. Case 2, addition of common salt to water. It is called dissolving. It is a physical change. Salt dissolves in water, we get salt solution. No new substance is formed. It is reversible. Salt can be got back through evaporation. Case 3, salt solution heating. It is also physical change. Evaporation takes place. Water evaporates on heating. Salt left behind. No new substance is formed. It is reversible. That is, water vapor can turn back into water. Case 4, addition of few iron nails. Iron nails react with water and air. New substance called rust is formed. It is not reversible. So in short, physical change, no new substance is formed, usually reversible. Examples: melting, dissolving and evaporation. The chemical change, new substance is formed, usually not reversible. The example is rusting of iron. Study the given diagram and answer the following question. See, here is beaker, ice, heating, beaker converting into water. A. Does the composition remain same? Yes. The composition in ice is H2O and water is also H2O. Composition does not change, is not changing. Name the type of change involved. It is a physical change. Melting, ice changes into water. Only state is changed, no new substance is formed. It is reversible. Write any two characteristics of the above change. No new substance is formed, it is reversible. Water can turn back into ice. Study the given diagram and try to answer. Beaker, ice, and heating, beaker, water. Okay, the same thing, I think it is repeated, right? Write any two characteristics. Okay, it is repeated. Next one. Next question. A desirable change is always associated with an undesirable change. Give example. Yes, a desirable change is always associated with undesirable change. For example, cooking of food. Cooking of food is a desirable change. The raw food is cooked and becomes tasty and soft. It is good for us to eat. But undesirable changes, during cooking, smoke and gases are produced. They may cause pollution and affect our health. Smoke and gases cause air pollution and may harm. So for every desirable change, there will be an undesirable change. So this is an example. For few, not every, for few we can say. Next one, name the elements with the following symbols. C, carbon, N, nitrogen, Si, silicon, Br, bromine, Cl, chlorine, Ag, silver, W, tungsten. Tungsten is the filament which is used in the bulb. Okay, it is an element. It is used as a filament. Hg, mercury, Co, cobalt and Cr is chromium. Define combining capacity match the following on number of atoms present in one molecule. See now, what is combining capacity? Combining capacity of an element is the number of atoms of another element with which it can combine. Okay, see here, carbon dioxide, calcium carbonate, aluminum chloride, hydrochloric acid, sodium carbonate and sulfuric acid. And at the right side, ferrous sulfide, sodium oxide, copper sulfate, methane, phosphorus acid and sulfur trioxide. This carbon dioxide combined with the sulfur trioxide, okay, that is F. And calcium carbonate combined with the sodium oxide, that is B. These reactions we will learn in future. Aluminum chloride will combine with copper sulfate, that is C. Hydrochloric acid, it will combine with ferrous sulfate, that is A. Sodium carbonate combined with methane. And sulfuric acid, it will combine with E, that is phosphoric acid. So this is what we call it as combining capacity. I mean, combining means they will react with each other. Next one, write the formula of compounds with the following formation. The names of the molecules: 2 phosphorus atoms, 5 oxygen atoms, that is P2O5. It is called as diphosphorus pentoxide because phosphorus will have 2 atoms, 2 means diphosphorus pentoxide. Next, 1 calcium atom, 2 oxygen atoms and 2 hydrogen atoms. CaOH taken twice, it is called as calcium hydroxide formula. Next, 1 iron atom, 1 sulfur and 4 oxygen atom, that is FeSO4, that is iron sulfate, FeSO4. 1 potassium atom, 1 chlorine atom and 3 oxygen atom, 1 potassium K, 1 chlorine Cl, KClO3, that is potassium chlorate. 3 sodium atoms, 1 phosphorus and 4 oxygen atoms, Na3PO4, that is sodium phosphate. Likewise, you have to write the formula. Representation of the following terms of their formulae: 5 atoms of sodium, 5 Na. So single 1, 2, 3, 4, 5. 3 molecules of oxygen, 3 O2. This is 1 O2 molecule, 2 second O2, third O2. 4 molecules of hydrochloric acid, HCl, 1 HCl, 2 HCl, 3 HCl, 4 HCl. 10 molecules of carbon monoxide, 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5, 10. 2 molecules of nitrogen dioxide, that is NO2 and NO2. So likewise, we can answer. Complete the following table. Name the compound, name of the compound, that is water. Atoms present in one molecule is 3 atoms, hydrogen 2 atoms and oxygen 1 atom, total 3 atoms. Carbon dioxide, CO2, it contains 1 carbon atom and 2 oxygen atoms, total 3 atoms. Sodium chloride, NaCl, 1 sodium atom and 1 chlorine atoms, total 2 atoms. Ammonia, NH3, nitrogen 1 and hydrogen 3, total 4 atoms. Methane, CH4, carbon 1 and 4 hydrogen atoms, that is total 5 atoms. A molecule is made up of 2 or more atoms. Different elements combine in a fixed ratio to form compound. The total number of atoms is the sum of all the atoms in molecule. Next one, molecule sodium hydroxide, elements sodium, hydrogen and oxygen. We are having total 3 number of atoms in a molecule, that is NaOH. Na, single sodium, single oxygen and single hydrogen. Calcium carbonate, it contains calcium, carbon and oxygen. CaCO3 formula, 3 oxygen atoms, 1 carbon and 1 calcium, total 5. Methane, CH4, 4 hydrogen atoms and 1 carbon, total 5. Nitrogen dioxide NO2, that is 1 plus 2, that is 3. Glucose C6H12O6, 6 plus 12 plus 6, that is 24. Baking soda NaHCO3, 1 sodium, 1 hydrogen, 1 carbon and 3, so total 6. Silicon dioxide SiO2, 1 silicon and 2 oxygen atom, 1 plus 2 is 3. Vinegar CH3COOH, it is also called as acetic acid. Okay, it is the weakest known acid. Remember that. The weakest acid is acetic acid. Okay, so 2 carbon atoms, hydrogens 4, 2 plus 4 plus 2 oxygen, total 8 atoms. Sugar C12H22O11, 12 plus 22 plus 11, 33 plus 12, that is totally we are having 45 atoms. So likewise we can count the number of atoms of one molecule. If you consider one molecule, okay, so one molecule 12 plus carbon it is having 12 and hydrogen it is having 22 and oxygen having 11. Arrange the following compounds in the increasing order of number of oxygen atoms. Okay, number of oxygen atoms in increasing order you have to arrange. Glucose, sugar, baking soda, sand, sulfuric acid. Glucose C6H12O6, sugar C12H22O11, baking soda NaHCO3, sand SiO2, sulfuric acid H2SO4. We have to write in the form of increasing order of the number of oxygen atom. Okay, increasing order. So glucose will have 6 oxygen atom, sugar contains 11 oxygen atoms, baking soda contains 3 oxygen atoms, so sand contains 2 oxygen atoms, sulfuric acid contains 4. So in increasing order, if you want to write, first you have to write sand. Okay, sand is the first one sand. Second one is 3 atoms, that is baking soda, number 2. First one sand, baking soda number 2. Okay, next 4 sulfuric acid number 3 and glucose number 4 and 5. So correct option is C. C is the right option. Likewise we have to answer. Okay children, thank you one and all. We will meet in the next class. Bye.